Good evening, all of you, dear participant, and welcome in this session. This is the ninth session of this tutorial series on MATLAB. Numerous topics has been covered related to symbolic mathematics with MATLAB. These tutorials are very important and play very useful information to write a program for operation research, optimization techniques, scientific computing, mathematical computing, and many more. I hope all the content which I am delivering are very helpful, very useful, and I hope you are getting the presentations. I have shared the two PPTs on the WhatsApp group, and if still you have any problem, you can put your questions in the chat box. Many of you are always regular participant in this series. Good evening, all of you. Dr. Jatshina, Anthony Arya, OKK, Vani Madhvi, and many more. Tashin Abbas. So all of you are a very regular participant, and some of are with us to join this meeting. So first I would like to share my screen. You can see this is my desktop, and this is the agenda of the today's session. The content which we will cover here, or we discuss the topic, are highly useful for the symbolic mathematics and their applications. In the last two sessions, we covered many topics related to the symbolic mathematics, but still in this session, little bit this session is associated with the previous two. But there are some technical problems when we are thinking about the content, and we have some problems. So this topic will be a little bit advanced from the previous two. So these are the content. First, we will cover the find symbolic variables in the expression, functions, matrices. Then after we have functional derivative, limits, integration. Obviously, in the previous lecture, we covered this topic, derivative, limit, and integration, but these are also concerned a little bit advanced, and we are using in a different way. Under this topic, we have the differentiation, derivative of expression with the several variables, derivative of symbolic matrices. When we have a matrix of functions and we want to differentiate, then how we can do, and the limits. Under this, we will discuss about the left limit, right limit, and the function limit. Then we have integration or integrals. Okay, so these topics we will discuss here in complete detail one by one. Okay, so as you know, how we can declare the symbolic variables in the MATLAB, and okay, so we usually use to declare the variable sims. Which variables are involving in our function? According to that, we decide and we use them. Okay. So to find the symbolic variable in an expression, function, matrix, we will use here SymVar function. Okay. We use so here we have just 1 minute. Okay. close it. Just 1 minute. I have some issue related to this presentation. Okay, you can see here we have a SymVar function, and SymVar function will be used to extract the variable, and this is very quite simple to use here. I am opening the, just 1 minute, I am opening in another way. Here is some issue. Okay, so now it is fine, and make it full size. Yeah, it's okay now. Yes. So this function will be used here. SymVar function will be used to extract the variable. SymVar is the combination of symbolic and variable. So the combining these two, we have SymVar, which is inbuilt function in the MATLAB. Suppose we have variables which were defined by using Sims function, which are a, b, n, t, and x. And here we have two functions. One is f is equal to x raised to power n, and second we have g is equal to sine at plus b. So when you will enter SymVar f, okay, so as you can see, f function have only two symbolic variables, and this will return this answer. Okay, so n and x, this will return in the form of index, and SymVar sorts all the returned variable alphabetically. Okay, the ordering here doesn't matter, but when this will return the values, these will be, we have alphabetically, as you can see, n and x. Okay, similarly here you can see a, t, and b. So here we have three symbolic variables, and when you will enter this statement, this will return all the symbolic variables which are involving. Okay, and if you have any question, you can, I can hear him clearly from. Someone is asking about the listening. I think I am proper audible to all of you, and if you have the problem, it may be from your side, but from his side, it is very quite fine. All the things are very fine from me. If anyone have any technical issue from his side, and I hope I am audible to all of you. Yes. Please let me know. I think I am okay, and my voice is very clear to all of you. Yes. So you can see this file, and these syntax which you can see here, these are the syntax which we use in the MATLAB. Okay, and this is the answer. When you will execute this above statement in the MATLAB, then you will have the corresponding answer. If you would like to see in the MATLAB, we can do some experiment here also. Okay, CLC, and see here I am using Sims. I have x, then y, t, and n. Okay, I have a function f is equal to, I am using sine. I have x, then product t, plus I have n product, okay, product y, and suppress this statement by using the semicolon. Here we will use here SymVar. SymVar will be used here, and see in this way when I will enter. So all the variables you can see in the f function we have x, t, n and y. Okay, and all the variables this will return in alphabetically order n, t, x and y. Okay, these are the variables which are involving in the function f. Okay, sometimes we need to define or required which variables are involving in the defining function. So we can easily use this function to extract all the variables which are involving in the function which you have defined. Okay, so whenever we have a long programming and we have several functions, then you need to assign the corresponding values to all the parameters for the numerical result. In that case, if any variable you did not assign the corresponding argument to the variable, in that case the MATLAB will not return the corresponding result. So this function play a very important role to extract all the variable and which values you have assigned, and if any variable is left to assign the value, then we can do easily. Okay, so here we have again you can use the same function SymVar to return first n variable. Suppose if you have the function is involving 5 or 6 variable and you want to check what are the first 2 variable or first 3 variables. In that case you can use the same function to extract the variables, first n variables from the expression, from the matrix or from the function also. So to specify the number of the symbolic variable that you want SymVar to return, we can use a second order parameter of the same. For example, you can see when you are using the SymVar function in this way, sim g comma 2. So this will return the first 2 variables which are involving in the function. Okay, so these are the first 2 variables in the g function, and the most important thing is notice that the first 2 variables in this case are not a and b. When you call SymVar function with the 2 argument, it finds the symbolic variables by their proximity to x before sorting them alphabetically. Okay, see once again in the same in the MATLAB. It is very important to use here. See again, if I am using here 2, okay, see which variables will be extracted here. So here you can see x and y. Okay, so the meaning is to say the closest variable to the x, because x is default variable in the MATLAB, and the closest variable to x will are close to x. Okay, and when you will use here 4, then use in this way. This will extract all the variables which are involving in the function. I hope you got this one. Okay, so now see here, you can, yes, here is one more example. This one is the similar to when you will call the SymVar function, okay, on the symbolic function. In that case, SymVar will return the function input before the other variables. Like you can see here, we have these are the x, y, w and z. These are the symbolic variables, and this is the function which is here f is involving w and z, and on the right hand side you can see x, w and y, z. So here f is function of only two variable w and z, but the other like x and y, these are the parameters in the form of a symbolic. Okay, so when you will use symbol f, so all the symbolic variables which are involving on the right hand side will be extracted at this place. Okay, and also we can have the two argument of the symbolic functions, and the symbol also follows this behavior. You can see at this place. Yes. Just 1 minute. Okay. Yes. Okay. So here, when you will extract by using the sim xyzw and fwz here. Now come here. If you do not specify an independent variable, okay, when performing the substitution, differentiation, or when you are going to differentiate a function and involving several variables, okay, and if you are not using the default variable, in that case it will choose x variable, okay, or the closest default variable, like you can see we have here is x, and on the right hand side y, w, here is s, t. Okay, if you are not assigning this variable, and in that case if you have a function which is involving s, t and u, these three variables are there in the function, and when you are going to differentiate by using diff function, f, and you are not using the default function, then what it will do, this will return the derivative with respect to u, because u is the closest variable to the default variable. In MATLAB, x is default variable, okay, and if you want to differentiate f with respect to u, then you have to use either this one, or you can use this statement also, diff and f. It will choose by default with respect to u. If you want to differentiate this function with respect to s, okay, if you want to differentiate with respect to s, then you have to use this statement f comma s. Otherwise, it will consider the default variable which is u, and u is the closest variable to x. This is the reason. So now when you are using the symbolic, one command is used to choose which variable is chosen as a default. Okay, so one is the first variable. One is the first default variable. Okay, so this statement will, okay, and f, we have a function of s plus t. If you are using here same over f1, so this will return t. So t is a default variable. Okay, so like s, we have t, then we have sorry, x. So t is the closest to x. T is closest to x. So this is the main reason t is the default variable. Okay. If you have question related to this one, because this is very important part while writing the different type of programs, then this will be very useful for all of you. Okay. and the understanding of the each concept is very important. I think you got it. Okay. So similarly, if you are using sims sx and tx, and you have sx tx, okay. So in this case also, when you will use sim var f1, then by default this will be the default variable. Okay, so in this way we can use all these we default variable, and then we can proceed to differentiate, or we can integrate. Otherwise, if you need particular integration, then we have to use in a different way. See, in the MATLAB, we have CLC, and we are using here sims x and y, a and u. Okay, then enter, and f is equal to, we have sign. We can choose here very simple, x plus y, x square and y cube. Okay, y cube. If we replace x, then it will be fine. If we replace f, then it will be fine. We are replacing into t and suppress it. If I differentiate with respect to, y, the reason is that y is closest to x. Okay, and if you want to check the same sim variable, and you can check here default variable by using this statement and enter. You can see y is the default variable. Okay, so this is the reason in the differentiate the same function with respect to t. Then see here, if you are using this statement to differentiate with respect to y, f with respect to y, okay, and you can see the result is same as we use for the this one. Okay, so either you can use if you are very clear about the default variable, then you can use this statement. Otherwise, if you want to differentiate with respect to y and you are not clear about the default variable, then you need to use this. And similarly, if you want to differentiate with respect to t, then you can use in this way, with respect to t. So this is the importance to extract the symbolic default variable. Sometimes it is very clear we have the particular symbolic variable, and sometimes when the function is involving multi-variables, in that case we have to check which one is the default variable, or we can do in the other way also. I present here several example. You can take one more example here. Suppose I have g is equal to, I have sine x product y product, I have t. Okay, so when I will enter, and if here diff function with respect to g, so this will return this answer. But as you can see, g function is involving x, y and t, so it is very clear that x is a default variable. Okay, So if you are using this statement, g comma x, and you can verify that the answer is same. But if you want to differentiate with respect to other variable, partial derivative of g function with respect to t, or either you can use here y. So this will be the partial derivative of g function with respect to y. Okay, so in this way we can declare the variable involving the symbolic and symbolic functions also, and symverb where will be used to extract the variables, how many variables are involving in the function, and which one is the default variable. You can use this statement to check. Again, you can use symverb, okay, and this will return g comma 1, and you can check to differentiate with respect to x. We need not required to use comma x. Okay, so now you can see here also by using the same statement, you can see here, and here, yes, this is a very quite interesting example for the differentiation. In the previous, this is the function involving only one variable. Okay, so exp, the meaning of this one is e raised to power x, and we want to differentiate g. So here you can check y diff g. Okay, y diff g. When you will use this statement, this will differentiate this function, and we will have the corresponding returning value derivative of g with respect to x in the MATLAB. Okay, MATLAB will return this answer. This is the answer of this statement. Now here is one more important function. Sometimes to find the derivative of g for a given value. Okay, and substitutes for the value using subs. Subs function is used to substitute the value and return the numerical value using VPA. We also discussed about the VPA in the coming slides. Find the derivative of g8x is equal to 2. So for that purpose, we will use this statement. We are using this statement. VPA is the function which will calculate all the values. Here y is the derivative. Okay, and we are substituting the value of x is equal to 2 by using sub function. Okay, very long answer. Okay, it is better if we can do all these steps in the MATLAB also, so that all the concept must be very clear. Yes, so I am using here CLC, and I have clear also. Again CLC, and I have g is equal to exp exponential function of x, and then product cosine x. So here is one problem. I did not define here the symbolic variable, so this will return error. Yes, since I can use g is equal to exponential x product cos x, and y is equal to, I have derivative of f, derivative of g, differentiate g with respect to x. Okay, So this will return the derivative of the above function. Now by using subs function, okay, we are using here subs function to substitute the value of x equal to 2 in y comma x comma 2. This is the statement, and when we will substitute x equal to 2 in y, where y is the derivative of the MATLAB, and this will return the numerical result of the statement. Okay, so see here, this is the subs function. Here I am using VA parenthesis, and on the right end also close it, and then enter. So here you can see we have the exact numerical value of the above statement, and simply you can use this as, yes, this is the G function. Once again check it, then we differentiate y with we differentiate G with respect to x. Okay, and the derivative of G stored in y. Again we are using here this statement VPA to calculate the numerical values of y 8x equal to 2, and the subs function is used to substitute the value of a variable in the given function. So here y is the function of x variable. Okay, y is the function of x variable, and the value of x we have is 2. So this is the required statement to get the required result. You can check it. Okay, so in this way we can easily use this one. Danish, good evening, and okay, thank you very much. Canada, I have not been able to use my sims function, always getting this error. Requires a symbolic math toolbox. Is it that? Yes, if the symbolic toolbox is not installed in your system, in your MATLAB, this is also the problem. This will not return the value you are using. Toolbox is required in the MATLAB. Only then you can do all these operations. Otherwise, you are not able to use this syntax in the MATLAB. Canada, this is a very interesting question from your side, and once again I'll let you show you here the list of all the symbolic variables in the MATLAB. Okay, see here is list of toolbox in MATLAB. So when you will search in the Google, and you can check here all the toolbox which are used in the MATLAB. Yes. So here you can see these are the toolboxes, like statistical and machine learning. Then we have curve fitting. Okay. And when you will scroll down, yes, here you can see curve fitting. Symbolic mathematics toolbox will be also there. So these are the toolboxes which we must have in our system. Only then you can use all these operations. Okay, you can find here also symbolic mathematics toolbox. Symbolic math toolbox. Yes, you can find. Okay, so this is the symbolic math toolbox, and you will get all the information about this symbolic math toolbox. And before going to start to use symbolic mathematics, you can find all plotting and manipulating symbolic math equations. You can create, run and share symbolic math code. Okay, a live editor is also there. The toolbox provide functions in the common mathematical areas: linear algebra, calculus, algebraic differential equations, equation simplification, equation manipulations, and many more. Okay, so all the information you can easily get about this symbolic math toolbox. If you don't have, you must you can purchase this toolbox. Yes, you need to purchase this one, and then you can use this toolbox. I think you got your answer. Otherwise, when you are installing the software in your MATLAB in your system, then you need to select which toolbox are required for your work, and then you can easily perform this type of operations. So while installing, you must be very clear about the toolboxes, of which toolboxes are required for your scientific computing. This is necessary. Okay, so you can see here many examples are also there, like calculus, solving, simplification and substitution, linear algebra. Okay, visualize, variable precision arithmetic, units and dimension analysis. So these all operations we can do in the symbolic math toolbox. I think you got to your answer. Yes, come to Ed's place. Now, if you need second order derivative of G, okay, so you can simply use this statement in the MATLAB. G is the function, and by default, this will differentiate with respect to X because J is function of only one variable. Okay, so this will return the second order second order derivative of G with respect to X, and the other way to find out the second order derivative, you can use this statement also, and you can compare the result at both places. You have same, so there is a different way to use a function. Okay, so either you can use this statement or you can use this statement for second order or third order derivative. If you need this third order derivative of G with respect to X, you can use this statement. So in general, we are using def G comma n, where n is any positive integer. Okay, you can find any order of derivative by using this statement. Or the other way, you can see here, this also you can use. Okay, here is one more interesting question for all of you. What is the derivative? What is the derivative of 5? And you know 5 is constant. 5 is constant. Can you please let me know what is the derivative of 5? If I will enter this statement in the MATLAB, what is the returning value? Please reply me in the anyone who can reply me. So you can see when I will enter, the derivative of 5 is not 0 here. This is returning the empty cell. Okay, so because this is the symbolic calculation, so for the symbolic calculations we need here symbolic constant is required. Only then we can do. See here, derivative of a constant, you must first define the constant as symbolic expression. This is very important. So here you can see C is equal to since 5. Okay, so 5 is symbolic constant. 5 is symbolic constant. Okay. And when I am using here diff C, the derivative of the same will be 0. Okay. So see here, you can check in the MATLAB if it is required. I am using C is equal to, I have C is equal to, it is the same, and here is 5. Okay. So when I will enter, and then diff C, and when I will enter, and you can see the derivative of C is 0, because C is, we have symbolic 5. So that's why we need to declare any constant in the symbolic, and then we can differentiate. So while using MATLAB, you must be very clear about a constant when you have any kind of equation, and sometimes you need to differentiate. Then these concepts will help you to avoid any kind of errors. Okay. Good evening, Sunny Abudkar, you got, and good evening, Salaudin. Johan, welcome in this session. Thank you very much to join this meeting. And also, I would like to inform you that if you have any question, please you can put in the chat box so that I can justify your questions. Yes. So I think this discussion is very clear to all of you. Okay. Now, when this part already has been discussed in the beginning, an expression that contains more than one symbolic variable, and specify the variable that you want to differentiate with respect to. We have to, when we have the several variables, in that case we need to specify. Otherwise, if we are not specify the same, then by default it will choose the closest variable to x variable, as we discussed in the beginning. Okay, so here is x, f is equal to, we have is this function, and we are using this statement to differentiate f with respect to t. So the statements which I am highlighting here are the MATLAB code. Okay, so the MATLAB code are the same as I am using here. We will check here. See in the MATLAB, there is one question in the chat box. Suppose I have CLC. Okay, and I am using here James X. Okay, then f is equal to x cap 3 plus I have x square plus 9. Okay, so press it, and diff f. I think you got your answer. Yes. It is returning the answer, as you can see here. Okay. So experiments are required. Now, if you want to calculate curl f upon curl t, okay, so this statement will return the value of partial derivative of f with respect to t, and you have the answer. So all these we have already discussed in the beginning. If we have the multiple variables, then how we can differentiate. Okay. So this is also the same. If you want to differentiate f with respect to s, then this will return the corresponding variable. Okay. So now here most important thing is, if you do not specify a variable to differentiate with respect to, so by default the MATLAB will choose default variable, and basically the default variable is a letter closest to x, as we explained about the default variable in the beginning also. So when we are not specify the derivative with respect to, in that case the MATLAB automatically choose the default variable which will be the closest to x in the alphabet. Okay. And in the preceding, for example, you can see diff will take the derivative of f with respect to t. Why? Because the t is closest, t is closer letter t than x. Okay. So you can see s, then t, then x. So by default, t is the symbolic variable which is the closest to x, and this becomes default variable. So when you are using only this statement, this will return the result with respect to t only. Okay. So here we have the function f is equal to sin st. Okay. See in the MATLAB. See in the MATLAB we have f is sims. We have sims s and t. Okay. And f is equal to, we have sin s product t. Suppose we have this one, and when we are using diff f only, okay, so f comma 1, this will return the default variable, and default variable in this function is t, which is the closest variable. Okay. Yes. Okay, now come here. This part has been discussed for the second order. If you need the second order partial derivative, you can use this statement. This will return the value of second order partial derivative with respect to t. Okay. By using this statement, you will get this value, which is this one. So when you will enter this, and note that diff f2 will return the same answer because t is the variable. Okay. So for the default variable, either you can use this statement or you can use this statement. Both have same meaning. Now here we are discussing yes, when we have symbolic matrix, and matrix involving functions like here you can see we can use the diff function to differentiate symbolic matrix as its input, and in this case the differentiation is done element by element. Consider this example. Suppose that we have sims ax, okay, and this is the A matrix. This is the first element, This is the second element, this is the third element, and this is the fourth element. So the first two elements are the first row, and this is the second row. Okay, so this is the symbolic matrix involving a and x function. So when you will enter this statement in the MATLAB, you will get this matrix. Okay, and when you will use this statement in the MATLAB, diff function we are using to differentiate a. Okay, and x is here default variable. So this will differentiate with respect to x. Okay, and the element by element derivative of a will be returned by using the same statement. So this will return, sorry, okay, something is missing. Okay, no problem. Come here. Just 1 minute. We are using yes, this is the code. Okay, so I have the syntax in the LaTeX also, and I can use directly. I copied from this place, and I am using in the MATLAB. CLC, yes. So seems AX, and when I will enter, I have this matrix, and when I will use diff function to differentiate A, and as you know, X is here default variable, and when I will enter, so this will return the derivative of A element by element differentiation of each element, which are the symbolic variable of matrix A. So in this way, we can differentiate each element of A with respect to X, and the another way you can also use comma X. Okay, the result we have them at both places. Sometimes if each element of matrix A are involving two variable or three variable, in that case we can specify according to our requirement. Okay. Thank you all of you. Yes, so again we have here you can see if we have we can get the value of Jacobian also. Okay, so to perform differentiation vector with respect to a vector argument, we can do also. Okay, and consider the transformation of a Euclidean space x by z to spherical. We have r, lambda, and phi, and the corresponding transformation we have is x is equal to r cos lambda cos phi, and y is equal to we have is r cos lambda sin phi, z is equal to we have is r sin lambda. So lambda is corresponding to the elevation and or latitude, where phi is denote the longitude. Okay, so the Jacobian of this transformation we can denote by this notation. This is the Jacobian of the transformation from the Cartesian to spherical. Okay, so x, y, and z are lambda and phi. So what we do here, we will choose L for lambda and F for phi. Okay, and then we will do here, yes, terms are LF, then we have x variable, y variable, and z variable. Okay, so x is equal to, we have is r cos lambda plus cos f phi, and r is y is function of uh, y is equal to, we have r cos 1 r cos lambda sine phi, and z we have is r sine lambda. So the Jacobian is given by this function. Jacobian is inbuilt function to for the Jacobian, and you can see this statement. This is the these three equations x, y, z. Then we want to differentiate these equations with respect to r, l, f. Okay, r, this is lambda, and this is phi. Okay, and here is mistake. Please correct this one. So this parenthesis must be closed. Only then this statement will work. Okay, so when you will execute this statement in the MATLAB, here is, this is the correct, this will return this answer. So this is the Jacobian option. So at this place, if you want to avoid this semicolon, you can use in this way x space z, then comma, we have r, then we have lambda, then we have phi, and this Jacobian. So this is the statement which you can use to find out the Jacobian of the transformation. And then after, if you want to find out the determinant, yes, we are using, will return the value after simplification. Okay, we can check in the MATLAB. Yes, come at this place. So we can save our time. I am copying from this place to all this statement. Yes. So these are the three equations, as you can see. Yes. Again, I have to copy because the last equation was not correct. Yes, come to in the MATLAB, TLC. Okay. So symbolic variables are r, lambda, f, and for lambda we are using L, and for phi we are using f. So these are the three equation. X, determinant of J will be equal to simplify. We are using simplify. Sorry, we are using here simplify. Determinant of J. Okay. Simplify, then determinant of J, and when we will enter, yes, this is the required answer. So after simplifying this Jacobian, we have this value. As you can calculate the limit by using limit function in the MATLAB. So the fundamental ideas of the calculus is to take the calculations on the functions is a variable gets close to or to fx plus h minus fx upon h. Okay, so provided that this limit must exist, and symbolic math toolbox software enables you to calculate this limit of the function directly by using the command. You can see here f is equal to, we have is sin x. Sorry, we are using here f is equal to cosine function. Okay, so we are choosing three symbolic variables. One is h, n, and x. Okay, so we can directly convert this statement into limit in this way, cosine x plus h, this function, minus cos x, this function, divided by h, this one, then h approaches to 0. The meaning of this statement is h approaches to 0. Okay, so this is the complete statement, and when we will execute this statement, we will have the derivative of cosine function. Okay, so the derivative of cosine we have is minus sine x. This will return the value. So this statement can be used to find out the derivative, and the most important thing is limit must exist. Okay, only then we have the corresponding derivative. Similarly, we can have this statement. So if you have a limit and x approaches to, here is n approaches to, yes, here is n. So we want to calculate the limit of this function, and the syntax of this one is, we are at this place. So limit function is there, and this one, 1 plus x by n raised to power n. We have this function. This function is at this place. Then we are taking the limit. So this is the limit. N approaches to infinity. The meaning of this part we have is n is approaches to infinity. So when you will run this statement or execute this statement in the MATLAB, we have this answer, e raised to power x. The meaning of this one is e raised to power x, and we know that the result is e raised to power x for this function. If you want to try in the MATLAB, we can do, see here. So CLC, then since we have x and n, okay, enter. Here is limit, then we have 1 plus x upon n and raised to power n. Okay, then comma, n approaches to infinity. N approaches to n. This is the infinity syntax in the MATLAB. Okay, so when you will enter this statement, syntax of the MATLAB, and syntax of the MATLAB in the symbolic math toolbox is very quite simple. Now again, if you can calculate this also. Yes. Here you can see how we can calculate left limit and right limit. We are discussing with the example of a function. Here x is approaching to 0 from left side, and we have this function. We have limit. We want to calculate limit. Okay, then we have this function. Limit you can do, and this is also very quite simple. Yes, for the right limit, this is the function. Okay, this is the limit, x approaches to 0, and this is the right. Okay, so when you will enter this statement, you will get the limit of this expression, which is 1. Okay, similarly, if a limit from left does not equal to the limit from right, left limit and right limit both are different at this place, and okay, matter will return nan. Nan means not a number. See, if you are using this statement, since x upon limit x upon abs x and x is equal to 0, so this will return nan in the MATLAB. Okay, some are new things. So just once we need to try. Here is f is equal to, I am choosing x upon abs x. Okay, this is the x function, f is a function. Now I want to calculate the limit, then I can use limit f is the function, then x is approaches to 0 from left. Okay, from left. So when you will enter, this is -1, and if you will enter, you can do, this is r. Okay, this is r, and this is L. This is L. Okay. And R is equal to L. 1 is equal to -1. Okay. So this is not possible. Left limit is -1 and right limit is 1. Okay, and then if you want to check, yes, the functional value at 0. If you are going to check the functional value at x equal to 0, see what happened. Here is nan. Here is nan, not a number. Okay. Now again we have, yes, these are the notations for integration. You can see here. So for the integral, just you need to understand the syntax. We will not go through the more detail about this because these are very quite simple. Just you need to follow the syntax only. So if you have x raised to power n and you want to integrate, so you can use this syntax int x raised to power n, or you can use this syntax int x raised to power n comma x. So both will return the answer. Check in the MATLAB. PLC sims x, int is used for the integration, and we want to integrate x raised to power. Here is one problem. PLC sims x and n. Okay, so int x raised to power n. So when I will enter, so you can see this is piecewise piecewise function. When we have n is equal to -1, okay, we have log x, and when n is not equal to -1, in that case we have x raised to power n plus 1 upon n plus 1, as you can see at this place. Okay, so when we have n is equal to -1, we have log x. Otherwise, we have x raised to power n minus 1. And in the MATLAB syntax, we have this expression. Okay, so I think you got it. Similarly, if you want to integrate sine 2x, okay, 0 to pi by 2. The syntax for the above is we have C, this is the int is used for integration, and this is the sine 2x, this is the lower limit, this is the upper limit pi by 2, and when you will execute this statement in the MATLAB, we have is equal to 1. Okay, otherwise you can use this statement 0 to pi by 2. Okay, you can use this statement only, and when you will enter, the answer is 1. Also, you can use at its place, and you can see we can use one of these two cases, but sometimes if a function is involving two variables, in that case we have to specify. Okay, again you can see here is this function j is equal to cos at plus b, and you want to integrate gt with respect to t, and the corresponding result will be this one. So you can see a, b is also there, and a is also variable. Okay, so these symbolic expressions also required to symbolize first, only then we can use. Okay, so this is the syntax for the integration. You can use or this one or this one. Okay, you can use one of these, and this is the g function in the MATLAB. And also you can integrate Jacobian functions. Integration of Jacobian 1 z is equal to minus j this one. Okay, so this is the corresponding syntax for the same int Bessel j 1. This is the first order Jacobian function z, or either you can use this syntax. So you can easily execute this statement in your MATLAB. After getting this file, I will provide you. Okay. Okay, alive. Good afternoon from good afternoon. Actually, here is good evening in India. Okay. So here I present some interesting questions, and I hope all the syntax which I am presenting here are very simple. And at the end also I will share this presentation on the WhatsApp group. This will help you. Okay. Some content which I want to include, but due to lack of time, I was not able to introduce all the syntax which I want to present here. But the last topic here is for definite integration, which we will discuss here. Okay. See. Yes. So this is the syntax for the same. If you have the definite integration. Okay. So a to b fx dx, and this is the corresponding command in the MATLAB which we need to use, int fab. Okay. And sometimes if you have the function in this way, a to b fb dv, then you need to use int fvab. Okay, so depends upon the function which one are given, and according to that you can use. Okay, so These are the content which I need to present today, and you must practice on this content. All these will be very helpful and useful in the coming sessions to write a different type of program in operation research or automation techniques, in symbolic mathematics, in for calculus, or to solve different type of models. Okay, so symbolic toolbox play very important role for the scientific computing. Thank you very much to see this lecture till the end, and you can share these recordings with your colleagues, with your friends, and the recordings of each session will be available forever on this channel. Okay, your suggestions are also welcome, because if you have any good suggestion which will make this session more interactive, more informative, more useful for all the participants, how we can help you more and more. So you can either write me on my WhatsApp, okay, or you can write me on my email address. Email addresses are available on the foundation website, which is mttf.in. Also, the most important thing is also I let you know we have now mobile app is. This mobile app will help you in many ways. You can easily download this mobile app by using MathTech Thinking Foundation. Okay, mobile app is there. All the international participants are requested. You can sign up by using your email address, and the participant from the India, you can either use your mobile number or email address. Okay, so all the sessions which we have organized at this place are also on the mobile app available there. This will always keep you updated, and the content also which we are presenting here will be uploaded there. So this will help you in many ways, because sometimes some participants may be there which are not on the WhatsApp group. So the participants who are not joined any WhatsApp group, you can easily download this mobile app and you can access the content which we are presenting here. Okay, so thank you very much for being the part of this session. Have a nice day. The next session will be held on the coming Sunday at the same time.